Today's video is going to talk about advancing OpenShift routes using a combination of DNS as well as security policies. In this case, it's going to be WAF. So this document demonstrates how CIS can really advance your OpenShift experience. And so the biggest thing about CIS is being able to expand the OpenShift route API to use multiple public IPs per host. And so without CIS using the default route API, you can only manage one public IP. And so a lot of F5 CIS customers have been saying or asking for multiple public IPs to front end all their routes. So in this example, we have a public IP Cafe 1 and a public IP Cafe 2 with a unique IP address. So you can see .65 and .66. So big IP front ending the cluster. OpenShift 4.11 cluster, and you can see that in the cluster there are 3 deployments of pods, coffee, tea, and mocha, and they're deployed in Cafe 1 namespace and Cafe 2 namespace. CIS is running inside the cluster, provisioning or configuring big IP. So the first thing we're going to do is we're going to create some routes for the Cafe, tea, and mocha service. And we're going to create those routes in OpenShift and watch how they get pushed or published to big IP. So we can see right here for Cafe 1, there's no routes. And on big IP, under the OpenShift partition, there is no virtual servers. So let's go ahead and create those routes. So as you can see right there, we created the 3 routes. We can actually watch the API. You can actually see there is the API success. You can actually see the routes have been admitted. So if we look at the route API, you can actually see within OpenShift Cafe 1 and on big IP, you can see the big IP. You can see the virtual right there. So what I'm going to do is I'm going to change this to Cafe 2. And let's go ahead and create the routes within Cafe 2. So changing my repo to Cafe 2 and OC create -f routes. You can see there's the API call. You can see right there, we've actually found there's the success of the routes. And so we should be able to see on big IP, which there we go. So there's Cafe 2. So we've got Cafe 1 and Cafe 2. And here within now Cafe 2, you can actually see the route is accepted. And we should be able to, we can hit this Cafe 2. So this is cafe2.example.com coffee. And we can go to mocha. And we can go to tea. So right there, the routes are created. And this is Cafe 2. If I want to go back to Cafe 1, I can change the namespace, go back to Cafe 1, and I can connect. There we go. So Cafe 1 and Cafe 2. So that's pretty cool. We can connect to all of our virtual servers. So now that the virtual servers are connected, we can connect to the virtuals on big IP for those 3 routes. You can actually see what the routes actually look like by expanding. It's just a very, very, very simple OpenShift route. So let's go ahead and open this in another tab. You can see that the Cafe 1, the routes, pretty simple, nothing really particular about the routes. We're doing termination of edge. There's a redirect in place. We're using referencing the edge termination, and we've got a health monitor. Pretty straightforward. Nothing really too complicated there. So the next thing that we want to do within this diagram is push our configurations out to DNS. So I think that's quite critical. So being able to push the configurations the DNS configurations out to DNS, so be able to create a wide IP. So if we go on to big IP and we take a look at our DNS configuration, you can see that we don't have any wide IPs. And so what would a wide IP? Wide IP would basically be available to push this out to do site-wide load balancing. So the DNS becomes the authoritative DNS server for Cafe 1 and Cafe 2. And then we can monitor the backend applications. So to be able to do that, there's really no ways that you can enable that through like an annotation. But what we can do is we can do a combination of external DNS configuration as well as leveraging our routes. Now, previously we were using a legacy-based API, and in this case, I am using the AS3-based API. So that's what this command says: CSOL GTM agent false. I actually just created another video on this as well. So there's a video today on this on YouTube talking about the differences and the changes between 2.11 and the API. So I'm not going to go into it too much, but you can see this is where my GTM API configuration, and this is where my configuration is for the multiple public IPs. I am using a config map to configure my public IPs. So let's go and take a look at that config map. And so if we look here at the OpenShift route, if we look here at the config map, so you can actually see what this config map actually looks like. So namespace Cafe 1, Cafe 2, and here are the virtual servers. So basically what happens is CIS merges this information with the route based on the namespace match. You can do label, route label. In my case, I'm doing namespace match, and you can see it's always overriding. And the other thing we have here is a policy CRD that we're implementing as well. I'll talk a little bit about the policy CRD in this demo. So let's configure our GTM configuration. And so to configure our GTM configuration, we're going to use an external CRD or an external DNS CRD. So let's go to Cafe 1 and we'll change to the CRDs, and let's look at this CRD. So you can see right here, let's go into Cafe 1 and let's take a look at the CRD. We're not doing anything new here. This has been around for a while. The only difference here is I have 3 monitors, and so the DNS is monitoring the application to make sure the application is up. If any of these monitors fail, I'm going to pull the A record. And the reason is because all of these URIs sit behind this domain name, cafe1.example.com. So we'll go ahead and deploy this, and we'll do OC create -F. Now this is a CRD, and so we'll do the EDNS piece, and you can see there is the API request right there. And so it's doing its magic to provision the DNS configuration. So we'll be able to see that shortly on the GTM piece. There is some requirements. Some requirements there is that virtual server discovery has to be enabled for this to work correctly. And so what virtual server discovery is doing is it's discovering the virtuals to make sure that those virtuals are in the pool so that they can get added to the wide IP. And you can see that the API was successful. So this should be able to come back. And you can see there is Cafe 1 and there's one pool member. So let's go ahead and create the second wide IP. So we'll create the second wide IP. We're still in Cafe 1. So change to Cafe 2. And go into CRDs, OC create -F, and this is our EDNS. So we've created the second one, and you can see there is the API request. That'll go ahead and get created in a minute. Now this is really outside of OpenShift, and really this is a CRD that is being created more like within Kubernetes. But what it's allowing CIS to do is configure the big IP with these with these wide IPs. And so the second one should be here in a minute. There is a little bit of, you can see that the health monitoring is kind of kicking in there. So there is a little bit of a delay. You can see here, there is a little bit of a delay because we actually have a buffer in place. This is part of the AS340 release to make sure that these pool members can actually be discovered. So you can see Cafe 1 and Cafe 2, these are the wide IPs. So if you point to this device as your authoritative DNS server, and if you query for cafe1.example.com, you will get this pool member. And so you will have one of these or multiple of these DNS big IPs in your site, and they'll be able to do site load balancing, or if you want to call it multi-site load balancing. So you can see here within my pool, there's two members. That's port 80 and port 443, and you can see right here the members are here. Port 80 is down, and this is actually getting removed. We should only show 443. So that's actually going to be fixed in. Actually, it's already fixed. It's just not in the 2.11 release. It's in the 2.11.1 release, where you only return one. So we're gonna basically only return the 443 because we only need to return one. This doesn't really matter. But you can see here is the virtual, and the reason we need a little bit of a buffer is just so that we can discover this information because we're using virtual server discovery. So that is our wide IPs that were created through OpenShift route. So you create your OpenShift route, and then you use the CRDs in combination with those routes. And it's really important because you can see this is my domain name for those routes. Honestly, it's pretty simple. I'm not doing anything complicated here other than creating an A record and enabling the monitoring. So that's actually quite cool. So now that I've got my routes created, I have my wide IPs created. The next thing I want to do, we go back to the diagram. The next thing I want to do is enable security. So security is a big thing for my OpenShift cluster. I want to make sure that the big IP doesn't allow mysterious traffic into the cluster. And mysterious traffic means anything that is not permitted. So this is obviously working based on signatures. And in my instance here, I'm making sure that my legitimate traffic meets the OWASP requirements. And so what I'm going to do is I'm going to go ahead and implement a WAF policy. So on the big IP, we have security, and we actually have an existing application policy called WAF policy. And it's actually blocking. And you can see that there, this policy is configured with some of the policies. In this case, it can kind of talk a little bit about, kind of like what is it blocking, right? In this case. So this is my WAF policy that is already enabled. The person that manages this is really outside of OpenShift. That's why it's this kind of separate task. So it's on the big IP. The thing is that it needs to be enabled. It needs to be enabled through it needs to be enabled on the virtual. And so what we've done to tie the WAF policy to the virtual is enable that through a policy configuration. So you can see right here, I have this policy configuration. So this policy configuration can be applied for the entire site. You can see that this policy configuration here is actually policy-cafe. And so this is really, if you want to call it corporate governance or network governance or security governance, and this is a policy for the entire site, right? So you can do different pod level security potentially on the pod itself, or you can do at different levels of security, but this is just really your inbound protecting your entire cluster. So this is a global policy. And you can see what this policy is utilizing a policy CRD. And right here, I have the implementation or the reference of a WAF policy. So anytime you create a route, what will happen is that this global policy will get enabled or get added to that route through the virtual IP address. And so that's what's happening here. And the second thing is we're going to log all requests. So the policy CRD is quite quite advanced in the way that it gives you a lot of options. If you wanted to configure advanced HTTP profiles, TCP profiles, you can also do bot, DOS. You can also do network security as well, known as AFM security. So there are multiple things or objects that you can configure for this policy. So this really prevents having to do lots of annotations, or the abstraction is removed, right? Because these are network policies, and the abstraction is removed out of the routes. And you'll notice here that this is the name. This is a different namespace. It's default namespace. It's completely removed or separated from your developer or your DevOps person that's creating the routes. They can go ahead and create the routes, and the security will get maintained through a global policy. And the global policy, again, is using the config map. And so that's what ties back to the global configuration. This is very similar to the way that we're splitting up the duties between, think about it as the gateway or the outside ADC or the outside load balancer, and the actual HTTP route. So gateway API is going to work very similar to this. The only difference is that this is a config map right now and not using the Kubernetes gateway API stuff. And the reason is OpenShift is just not there. And it's still new, where this right here, you can actually physically go and implement because it's actually shipping right now. And it's also fully supported. So you can see right here that my extended spec, Cafe 1, has this policy that it's invoking, this policy Cafe, and Cafe 2 has the same policy. And so this policy has then been applied to that virtual. So when I created the virtual, this policy was there. All I had to do was create that policy CRD, but that policy CRD is already applied. I applied the policy CRD before I started the demo. So what we can do is we can go look at our virtual server here, and if I click on one of these virtual servers, if I go to security, you can actually see that the policy is actually enabled, as well as login all requests. And that is because the policy CRD was added, and CIS merged the policy CRD with the virtual. And so that's why you see that policy CRD referenced here. So if I go back to, let's see, Cafe 1, if I go back here, and if I start to do some let's go ahead here and put why not, an alert 60, just basically some cross-site scripting or some example attacking here, you can see that this is going to be blocked, right? So I could manipulate this, but ultimately what I'm doing is I'm injecting invalid, or I'm injecting malicious type traffic in the URI. And so WAF rejected that. So it didn't even get into the OpenShift cluster. It got dropped at the edge. And so by the big IP. And the thing that you can do, you can see it here, is if you go to event logs, you can actually see that actually getting, this was for T, and then here, WAF policy. So this was a valid request. You can see the request came in here. But as soon as I came in and started sending these fancy request characters here, this thing got dropped right away, and you can actually see the drop here. Now you can do many different things with WAF outside the scope of this video, but you can see that all of these were dropped, and the message that I got back from the big IP was this URL was rejected, contact your administrator, and I think this is the support ID, etc. So you can manipulate this message, but ultimately, what that allows me to do with the advanced routes is, first of all, create multiple public IPs for a group of routes. And the public IPs can be in one namespace, and the group of routes potentially can be in a different namespace. You can use route labels. In my case, my public IP is in the same namespace as the route itself. That makes sense. So Cafe 1, different public IPs in different routes. So this is great. You can allocate potentially a different public IP for a different group. So maybe HR or different apps, maybe app 1, app 2, in my case, Cafe 1, Cafe 2. And then what you can do is you can tie the routes back. Then you can tie different security policies or different policy CRDs or to your different two different routes. So obviously, there are lots of different things you can do within the policy CRD, because at the end of the day, it's referencing a policy that is on big IP, right? So if Cafe 1 wants to have a different policy than Cafe 2, you can just have two different policy CRDs. In my case, one policy CRD, because I'm really focusing on WAF at this point. The third piece is creation of the wide IPs. So to make this site aware. So now that I am taking this route, exporting this route from just the cluster itself, not out to the big IP, and now to be able to do site aware or site-wide load balancing. So those are the three really good examples that I've kind of talked a little bit about by advancing OpenShift routes using external DNS. The other thing here, just to kind of finish, this is also using ovn-kubernetes. So this is the latest 4.11 using ovn-kubernetes. And what ovn-kubernetes allows me to do is support high availability. So you can see here there's a high availability cluster, and I'm also not using any CNI. So I've created videos on that. This is the same infrastructure. Just take a look at my YouTube channel and you'll see to do ovn-kubernetes with no overlay. That is there as well. So if you have any questions on this, there's a lot that we covered here. Please send me a message. If you like this video, give it a thumbs up, like the video, and if you're not subscribed, please subscribe. Thank you.